Hello, everyone. Welcome to the course ITS 140. Can you guys hear me?
Yeah.
Yeah, I can hear you.
Yeah.
All right. Welcome to class. So let's get started here. I'm going to share my screen. All right. So you should be seeing a PowerPoint slide, correct?
Yeah, I'm seeing that. Oh,
Yeah.
sorry.
Input processing and output. So that's going to be our first programming topic. I've already gone on Brightspace and I have added, I think, the first 4 or 5 modules of the course. So they will be inputs and outputs, which is this one. Then that's going to be followed by if statements, or what are called conditional structures, Boolean logic. Then we're going to do iterative structures, which are loops. And then after that, we're going to do modules and functions. All right, so that should be like the first set of topics that we cover in a programming class. You will also see that in every module, I've posted 2 sets of slides. One set of slides is from the old book, which is, all the books are by the same author, so they're pretty much related. The old book is just no programming. It was just logic and pseudocode. A new book is basically the same, but with more Python in it. And so what you will see me is I basically put both slides that are related together. I will start with starting out with programming logic and design. And then from there, I will move through those topics, then move through the Python slides, and I'll skip some of the slides that I've already covered in the previous one. So the plan this week, you'll have your first homework assignment. So today I'm just going to lecture. On Thursday, I'm going to, assign a homework and then just work out some problems on the board, basically, on the whiteboard here. So, I'll read the problem and then you can just follow along. Okay, and we'll try to solve the problem. So we'll solve a few problems in class. And then from there, I might go over in class just a few questions, multiple choice, that kind of thing, verbally, just, to do that. And then from there, yeah, I'll give you a little bit of time to work out some problems, ask questions, things of that nature. Okay, so the focus this week is going to be, chapter 2, basically, input, processing, and output. So if you're following along in the book, go ahead, read through it. Certainly the books are pretty good. I just think they're a little bit pricey. Remember, you can always get the older copies if they're cheaper, used ones. The only thing that you need from the books is the end of chapter problem. So I will write, put those on Brightspace so that what problems to work on. Usually it won't be that many problems. But of course, if you want to buy the book, that's entirely your choice. All right, before I get started with the slides today, are there any questions? All right, no questions. That's great. I remind you, you can also you can send me emails, or you can also send the teaching assistant, Mr. Mitch Burke, so he can help you with software, things like that at this time. All right, so yeah, let's get started then. Should be pretty fun, this approach. Okay, so let me bring up the slides. All right, so you should be seeing the slides. So these are from the old book. And so the chapter topics are basically how to design a program. And so the idea is, and you know, usually I like to tie things to the homework assignment. So in the homework assignment, you'll get problems, you know, some kind of problem, and you have to think about it. How would I solve this? How would I solve this by hand? How would I solve this? How do I write the steps to solve this? How do I create like a little diagram or flow chart or something that allows me to better represent the ideas in this? And in particular, computer programs are about data flowing through things. They're really like graphs, you know, you have some data and the data is flowing through the graph, okay? And so, you know, we'll certainly look at that, flow charts. And then after that, you end up with what is called pseudocode. And then that pseudocode eventually gets written into, you know, a programming language such as Python or C++. Now, in the beginning, you are not going to, in the beginning, you're going to, programming, even for very small, simple programs, it's going to take a very long time. Okay? It's going to take a while for you to do all these steps. Eventually, as you get more practice programming, you know, programming is like anything else, right? So you want to become really good at playing the violin, you know, it's not going to come overnight. You have to really, really practice, learn, right? And so it's the same with programming. With programming, you learn. The great thing about programming, as I've said, is that it's always the basic same principles. The same principles apply to all programming languages. And so it's gonna be a matter of learning, and then also of practicing. You know, finding ever more complex problems. You know, and as you know, in the world that you guys live in, you know, it's a very interesting world. You know, you can do anything with software almost. So, and it just keeps getting better. So certainly this is a skill that you have to master. And as I said, you know, one thing I always tell students is, you know, take it easy. Don't worry about it. You'll get it. It'll take time. Even after 4 years, you know, you still will need more practice. All right. So the chapter topics: designing a program. Okay. Then you have your output, input, and variables. So that's just going to be, you know, we have a problem. Obviously, we're going to need data. We need to do something with that data. And then once we process the data, we're going to have some kind of an output. We also need a place to store the data, and that is usually called variables. So we're going to put our information in memory in variables, right? So that's a topic that I'm going to basically introduce today. There are various ways of dealing with variables, but at the end of the day, they're just space and memory. You know, you allocate buffer space and memory, and that's it. Then after that, once you've created your variables, you're going to have variable assignment and calculations. All right. You know, so how do you assign to a variable? You have variable declarations and data types. So that's going to vary quite a bit between programming languages. So from strongly typed, what are called strongly typed programming languages like C++, to very weakly typed programming languages like Python. Okay, so you'll see data types just means, okay, is this a string? Is this an integer? Is this a real number, also called a float? Is this Boolean? You know, so how are you storing the data? But remember, you know, from last week's lecture, remember that at the end of the day, all of that is being stored as bits in bytes. So the key idea is, you know, how many bytes or bits do you need to store the information? Okay, so that's really the main issue there. Okay, then we have constants. So, you know, putting in, you know, instead of a variable, you know, assigning a constant, hand tracing a program, which is code auditing, right? So what you do is you read a program and you flow through. It's nice, like if you can, you know, follow through, you know, a variable. So it starts, you know, this is the first number is 7, and then I'm gonna follow along the entire program until I find what I'm looking for. So hand tracing there. Documenting the program, you always want to do that, you know, a program may be complicated, and sometimes you have to, you spend a lot of time trying to figure it out, and then you leave it for a month or two, come back, and you forget about it. So it's always good to have, comments within the code, documents to support it outside, etc., as much as possible. Nowadays, people do this online. Everything is done online, right? And so there's something called GitHub nowadays. And GitHub is a website is built for you to put your code there. You can put a README with the documentation. It's got the comments. It's accessible. You can share it with people. You can reference it yourself. Whenever you have you don't remember something and you've done it, you can just check there. But certainly GitHub, I highly recommend that you start using it as soon as possible. And then designing your first program. Obviously, that's what we're going to do this week. So this week, we're just going to take it slow, go through the process. As I said, on my plan on Thursday, is just really to go through some problems and help you out with that. So designing a program, right? The first step in programming is designing, right? So you don't, in a sense, the idea here is that you don't want to just, okay, I'm going to start writing code and, hope that it works right now. You don't want to do that. Instead, you want to take your time. You want to take your time. Oh, this reminds me, I'm going to take the course participation. I forget. Before I forget, because I just remembered, I see people coming in. Make sure you have your names on this screen, because otherwise I won't be able to do the course participation. Okay, so that should take care of that. Sorry about that. Okay, let's go back to the slide. Okay, so designing a program. So the first step is designing. That just means take your time. Usually that, if you want to have a structured way of designing, you have two steps. You have a flowchart and a pseudocode, right? And that just, as I said, is computer programs are just flow of data through operations. That's basically it. And so you can create flowcharts of that, right? And we will explore that. I'm not going to drive that point to death, but we're certainly going to do a few exercises on that. And then pseudocode is really important because it just shows logic. And so the idea here is that your brain develops ability, right? So if you ever like to play chess or play games that are, complex puzzles, things like that, you develop a certain logic about doing things. And that's the same with programming, right? It's a fun thing, And so we need to write the pseudocode set of steps. All right. And then after that, usually you would write your code, which, for our purposes, it'll be, Python. And then the code, when you write the code, you have something called syntax. And what that means is that you have a set of rules and a set of reserved words. Okay, so whenever you want to do, a process in a loop, you can't just say, oh, loop here, right? So that would be pseudocode. You have to use what is called a reserved word, such as the for loop, the for keyword in Python, or the while keyword. So you have to use that, and then there's certain rules about how to write programs. So for instance, with C, C++, you use curly brackets. So whenever you start a block of code, you use curly brackets. Whereas in Python, what you do is you just use indentation. and you have to be consistent. So here, for instance, that indentation is usually a tab, but I prefer 4 spaces. That's just me. And you just have to be consistent with that. It's always going to be 4 spaces, or it could be 1 tab or 2 tabs. It's a preference of how you like the code to look. You'll certainly see me, my approach, but it's entirely, you'll develop your own ways of doing things. Okay. After the execute, and then after you've done things, you either compile or you just run it through the interpreter, but you basically run your program. And then, of course, just because you cleared syntax errors, it doesn't mean that you've cleared logic errors. And logic errors come when you misunderstood the problem and you didn't implement it quite as it should have, or you understood the problem, but your logic is incorrect. So you don't, as we will see, there's a lot of interesting logic things that we can do with programming. So it's really a fun thing to explore. If logic errors exist, the program must be debugged. Remember that debug just means that you have to go back, you have to trace basically the code and find errors in your logic. Usually what is good to do is you just run through the program, right? You run, okay, if I enter this and then I do this statement, I should get this. And then you're testing it with the program, then you go to the next step. Okay, great, that worked. And now, and I'll show you guys how to do that. There are various ways that you can do it. Okay, so let's keep going. So the purpose of programming logic and design is to focus on flowcharts and pseudocode. Okay, that's true. So basically, we can look at this class as 2 things. Programming logic and design, and then implementing what you created in your flowcharts and pseudocode in Python. Okay. So as I said, we'll have to do a little bit of flowcharting and some pseudocode writing at first. Okay. The design is the foundation of a good program, and you can see here. Here's a little graph of the life cycle, the development life cycle. So you design the program there, then you write the code, correct syntax errors. You have to test that everything works, and then it usually won't at first. And then you have to debug it. And then, as you can see, it's a cycle, and you have to continue doing that and refining and refining and refining over time. Okay. So now let's look a little bit about, in more detail, the design process. Okay. So there's 2 steps in designing a program. First of all, you have to understand the tasks that the program is to perform. Understand the task. Okay, you want to do that. Learning what the customer wants. So usually, if you work for a company, let's say in web development, you need to develop a website with a lot of JavaScript that creates a very nice dynamic experience. You really have to talk to the client, right? Whoever wants the program, get everything very well documented, understand what it is that they want. So, and for the class this semester, all the problems that we're going to do, you have to really think about the problem. So you'll see that will be the challenge, right? There's going to be problems about, a lot of things, payroll, or, if you're implementing a system in a car or a plane, how would the logic work? And so that's really one of the main things that we're going to discuss. And then once you understand the problem, once you understood the problem, then you determine the steps that must be taken to perform the task. That's the next one, right? So you have to determine the steps, and that is called the algorithm, right? So you create the algorithm, which is nothing more than a step-by-step directions to solve a problem. Remember that computers, they do a certain set of tasks. We talked about it last week. You know, they process numbers. And so we have to work with that to solve the things that we want to solve. But ultimately, we want to create our algorithm. And so tools that will help us to improve our logic include flowcharts and pseudocode. All right, so let's take an example here at pseudocode. Okay, so pseudocode, you know, you can call it fake code. It's a model for programs. There's no syntax rules, although you should try to follow a certain structure every time, okay? You know, even though there's not a fixed set of rules because you're not going to run this, you should always use the same keywords to indicate things. So because, you know, if you do that, you know, that the better you do your pseudocode, the better it'll be to convert it to the actual code. So let's take a look at an example here. Right, so as you can see, our very first programs are very simple, right? All we're doing is imagine you're in a computer, like a terminal type of thing, and there's the prompt. And the prompt is, you know, is just blinking. And now, you know, what do you have to do? Well, you want to process something. So you're going to type something, press enter, and get output with some more instructions, type something, hit enter, and so on, right? And that's what a program does, right? Those are used to be called console programs. They're just sequential programs, you know, and that's kind of where we start with a lot of our logic. It's just sequential. We're going to do things in a sequence, you know. So imagine, you know, the sequence is like that through the program, line by line, okay? So the first thing, you know, imagine this program. The first thing it does is it displays on the terminal, enter the number of hours. So imagine you have a little terminal, and then you get that message, enter the number of hours. So then what you do, the prompt is going to wait for you to type something. So enter the number of hours, and you can say, okay, 40 hours a week or something. And then it's going to say, once you hit enter, right, enter there, then it's going to prompt another message, and it's going to say, now display, enter the hourly rate, or the hourly pay rate, right? So you've entered 40 hours, and now you're going to say, okay, you know, $12, and that just implies $12 an hour, okay, because it's saying hourly pay rate. Now, if you entered, you know, even though this says hourly, if you entered pay rate per day, you know, $100, let's say, you know, that would be wrong. That would be a logic error, right? Because your input did not follow the instructions that you were given. Okay, so definitely that's a possibility for an error, but you have to, you know, follow the rules. So then once you do that, you enter, you know, let's say $12 an hour. Okay, you hit enter again. And now what's going to happen is inside the program, you're going to have a formula. You have an equation in there. And notice you say set, and now you're going to take what you stored in hours, because the 40 was stored in hours. So in this one, you stored 40, and then pay rate stores 12, okay? And so now you have hours here, which is this one, and you have pay rate, which is that one. Those are called variables, and that's where you're storing your data in memory. Now, this is just a multiplication. Notice that we use the asterisk multiplication. We will look at operators in a sec. And you perform the multiplication, and now another variable, gross pay, will contain the result of multiplying 40 times 12. Okay, that result then, notice here, the last part will be to display a message. The gross pay is in dollars, and then notice the comma there, and then gross pay. So that's a pretty standard, you know, Python-y or Pythonic approach to printing things, and we will see that later. But you're just printing out the results. So for completion here, then, you know, you would do, let me do, it would be 40 times 12, 480. Okay, and that's what you're going to get as your output plus the message. So I should have, you know, it'll be the message. So it'll say the gross pay is, and it was 480. Okay, $480, and that's really what happens there. That's your very first, if you know, program. That's your first pseudocode. That's your first input and output program. Are there any questions about this code at this time? Pretty simple. You know, for some of you, this might be very simple, especially if you've taken a programming class before. For others, you know, might be the first time you've ever seen this. So. All right, so it seems like there's no questions, so let's move on then. Okay, so now flowcharts. If you look here, we've got famous flowcharts. Everybody that programs, you know, will see this at some point, right? So this is a very common or very standard approach to learning programming. You basically see flowcharts. So we're gonna look at a calculating program, okay? Calculating program. So first of all, what is a flowchart? A flowchart is a diagram that graphically depicts the steps that take place in a program. So as I said, you know, programs are flows of data, right? And so with the steps. So usually you have a few symbols that are important, and just, you know, be consistent when you do these as part of your homework. So first, you know, the inputs and outputs are going to look like that, right? So terminator used for start and stop of the program, right? So it's not inputs and outputs, sorry, the terminator. So that's basically just to indicate the program starts here, the program ends there. You use a parallelogram, it's this, for inputs and outputs. So whenever you're printing to the screen, or whenever you are taking in an input, like, you know, what is the your pay rate, right? So then, you know, you take in that pay rate through and you depict that in a flow chart using that symbol. And then finally, this is pretty standard for a lot of flow charting approaches. You use a rectangle for processes. So processes are imagine anything where you have a computation, some kind of an action that takes place, maybe that modifies your data, you know, some kind of calculation. So if we look at the previous example where we had this, right, that was our first program in pseudocode. We can see here the flow chart, right? You can see there the flow chart, and I'll just point out a few things. Notice that this program really only has one rectangle, right? Only one rectangle, so that means that's the process. And then it's got several inputs and outputs. You know, a lot of the time, not always, but a lot of the time, especially in the beginning, you know, you'll have a lot of inputs and outputs. Over time, the processes are going to be more. You have a lot of processing to do. Okay, so here we have, you know, the first parallelogram just displays the message. Enter the hours the employee worked, right? So it's an output. This is an output. Because you're printing out to the screen a message. Then you input the hour, so that's going to be the equivalent of having that prompt and where you entered 40, right? So that's going to be an input. Okay. Then the next step is after you hit enter, right? So you hit enter here, right? And then once you've hit enter, then now you have another display, so it's another output. Okay, that's an output there. Display, enter the employee hourly pay rate. Then after that, you have another input. All right, and you input, imagine that. So it would be, $12 an hour. Input the pay rate. Okay, and then you have the process now, which is a square, right, like that one. And it's going to be, set gross pay, which is gross pay is going to be equal to hours times pay rate. And then the result of that is going to be to display the employee's gross pay and the result of the calculation. So this is another output. Okay, and this, let's just say this is a process. Some kind of a calculation and so on. Are there any questions about this, guys?
So my question is, so for the rectangle, so if it's multiplying or putting anything together, that counts as the process instead of the output?
Can you speak up a little bit? I could barely hear you.
So for the rectangle.
The rectangle, yes?
Yeah. So if it's multiplying something to get data, that counts as the process,
yes.
Not an output.
Not an output. It's something that's only happening in memory. You're not seeing an output yet, right? But it is, and it's not taking inputs from the human. It's taking inputs from memory. So data is flowing from places in memory. You're right, because it's, the hours and pay rate are in memory, but it's not inputs and outputs from the outside of the program. It's something internal, and it's basically processing. And so it's called a process. Make sense?
Yeah, I got it.
Okay, good. All right, good question. All right, so let's continue then. So output, input, and variables. Right, so we're going to define that a little bit more. So output, data that is generated and displayed, right? So messages, results of calculations. Okay. Then we have inputs, and that's data that a program receives. Okay, so from the outside, let's define, right? Not necessarily reading from a variable in memory, but just reading, an input from the user. We're going to see that Python, for instance, is a two very handy functions. One is called a print function, right? And that's for outputs. And then we're going to have one, called the input function. All right, and both of those are going to allow us to, get our inputs or print out our outputs. Variables, those are just storage locations in memory. Okay, so those can be very complex to set up or very easy depending on the programming language. And so programs will typically follow these three steps. The input is received. You perform some process on the input, and then you get an output. Okay, so that's, sometimes your input is going to be data in a file, so it's not going to be directly typed by the user, but it's actually already in some file. So we'll see about that as well much later in the semester. But that's also a possibility. So let's talk a little bit about the display or the output, right? So this is called a command prompt, a terminal, console. It's really just an interface. So we're used to writing programs that have GUI interfaces with buttons. Certainly in the web that's common, but a lot of our programs have that. We bring up a window, and the window has labels, text boxes, buttons. But there's also the console, which is a little terminal, right? In our Jupyter notebooks, for instance, it's just really where we type the code is like the prompt, the terminal. When we run it and it prints it on the page, that's like the output. So it's really very, very much like a console as well. Only it's nicer than just this text-based approach. So the display is usually in the pseudocode. Display is the keyword to show output, to show output to the screen. Okay. Now, another thing about programs is that they're sequential. I've said that a couple of times. So that just means that every line executes in order, as in the order that they appear. So they execute one line at a time. A string literal, that's another term that we're going to learn about, is basically a sequence of characters. So whenever we type text, like you can see here, you have some addresses, etc., right? And that's just it's called a string literal. It's just a string. It's not a variable per se. It's just something that you have on there to print out. So when we use the print statement, I think I did this last week. I did hello world. All right, and that's a print statement there. All right, so that's a string literal. All right, so you can see here the statement. Here the statements, we have 3 display statements, and they execute in order. So we're going to say display Kate Austin, display her address, the city, state, zip code, and you can see that all of that is displayed there in sequential order. Right, so a lot of what we do will be like that in our first programs. We'll have some lines of code, and they will generate some output of some kind. So input is the keyword that we're going to use in pseudocode to take values from the user of the program. So remember, that's kind of the distinction when we're talking about input, is that we're reading everything from the user. And then you store it usually in variables. So you can see here, for instance, we have a display, which is an output. Then you have input age. You're assuming that age has been defined as some variable, or you're going to be using it as a variable. Then you have another display, another output. Here's the value that you entered. And notice that now, instead of inputting age, we're just displaying it. So this would be you can see the program down here. It shows what is your age. Then you enter 24 and you hit enter. And then it just repeats it back to you. So it says, here's the value that you entered, 24. And that's it. So it's pretty simple. This is the easiest, simplest topic in this course. It's pretty straightforward, really. And so on Thursday, one of the things I will do is I will demo this, using our Jupyter notebook. Just go through some exercises very, very simply. But, I do want to stress that in the beginning, I want us to spend a little bit of time on the pseudocode. That doesn't mean that you can't write your pseudocode in the Jupyter notebook. There's really, you can do it there. So it's pretty much, you can do a lot on there. Okay. Now, what about, variables, right? Variables. Variables are important, of course. And as the name implies, they're places in memory that are going to vary. So that means that usually there are variables for calculations, that as you start entering values and performing processes of math operations, things are going to change. So they change from one thing to another and so on. Now, you're going to have to create variables and give them names, because that's how you reference them. So there's good ways of creating variables, and there's bad ways of creating variables. If you have a program that has 20 variables and you call them A, B, BB, C1, X37, it's going to be virtually impossible for you to remember, okay, what was this one for? So you have to really give them descriptive names, okay? So there are some rules that you can follow, okay? So first of all, it should be one word, no spaces. So that's a definite rule. No spaces are allowed, okay? It's got to be one word. And you can make a one word of 2 words. Usually the convention is you'll do something like, my list. As you can see, it's 2 words, but you capitalize the first letter of the second word. And you can do that with multiple combinations. So you want your program certainly to be as clear and descriptive as possible. Generally, punctuation characters are avoided. So don't use like exclamation. Now you can use underscore, for instance, you know, but don't use question marks, exclamation, things like that. The first character cannot be a number, generally speaking. It's not going to, programming languages will not want you to do that. And name a variable something that indicates what may be stored in it. Okay, you know, as I said. So for instance, my list would be incomplete there because it doesn't really say what this is for. But if you said my list of courses, okay, that variable now has a lot more meaning. You know, you're writing some kind of a program related to students, and there you have, you know, that. And you can see that here, right? That's an example just like the one I did above. So variable assignment, you know, sometimes you can assign, you don't always have to take a value for a variable from the user. You know, you for instance know, you know, what year it is, right? So, you know, you don't have to always ask the person. You can just say set year, you know, 2020. Classic year, right? One for the history books. And so you can certainly assign variables inside the program itself. So variable assignment does not always have to come from the user input. It can also be set through an assignment statement, such as this one, assign 20. All right, so right now I'm just randomly talking about assigning things. Later on, we have to get a little bit more specific about the types of things we can assign. You can see that here. We set dollars to 275. Notice this is a decimal number, right? So you have a float, what is called a float, real number. Then you can also display a message, like a string literal here. Again, another float, another string literal. So we're setting it in, you know, this set implies that the program is being set. It doesn't, you know, it doesn't say input, right? So there's no input as if to say, oh, it came from the user like we had before, where we had input age, for instance, right? So we're not doing that. Here we're just setting. So that's another very common pseudocode type of word, okay? Pseudocode type of word. And you can see here then, if you notice here, I have comma. So notice the commas. So there's a comma there and a comma here. So there's really three pieces in that display. There is, I have in double quotes, you can see the double quotes there. That's a string, literal, comma, dollars, which dollars is whatever you set in this variable. So it gets plugged in there. So 275. And then another string literal in my account. Notice also there's a space right there. Okay, and so basically this allows us to print combined things of the string literal, a value in a variable, another string literal. And so I have 275 in my account, okay? Which means, you know, you're in trouble. All right, so now we have another example over here, 99.95, and you do the same thing. But now I have comma, dollars. Now it's this, notice that the dollars have changed in my account, okay? So you can see that there as well. And that produces then this display statement, pieces together three things, three strings, a string literal, but now I have the value in dollars, which is 99.95, and the other string literal in my account, which notice has a space right there. There's a space right there. Those spaces account for this space and that space. If you didn't add those spaces, then you know, you would have a single word. So all of this would be like one single word, and that's not very readable. All right, are there any questions about anything that I just said? Okay, no questions? You guys still there, correct? Let's see.
Yep.
Great. Okay, so now that
I'm here too.
Good. All right, so now that we have, talked a little bit about that, let's move on to, math operations. So math operators. So computer programs are really good at this, right? So computer programs are really good at, like calculations, right? So variable assignment and calculation. So what are some of the operations that you want to do? So usually you want to add, multiply, the kinds of things that you would do in a, let's think of like a business, right? A business wants to calculate your payroll, so it needs to perform. So calculations are performed using math operators. The expression is normally stored in variables. So for instance, you're gonna, again, take two variables, let's say price, discount, right? And now you have a subtraction, right? You have a subtraction there. That's the symbol. And then after performing that operation, the result of that gets assigned to the sale variable. Sale variable. All right, so what are some common operators that we will be using? And these basically appear exactly like this in Python or pretty close to it. I think the only one that might be a little bit different is this one in Python is a percentage, and this is actually, the exponent is 2 asterisks. But we will see that later, so don't worry about it. And that's an example of pseudocode versus syntax, right? So this mod would be pseudocode, percentage would be syntax. Okay, so some of the common operators, we have obviously addition, right? Adds 2 numbers, so it adds 2 numbers. We have subtraction, right? And that subtracts 1 number from another. Multiplication, notice it's an asterisk, multiplies 1 number by another number. And we have division. See that there, that's the symbol. It's forward bracket, or forward slash, sorry, forward slash. And it divides 1 number by another and gives the quotient, right? Then we have the modulus operation. And the modulus operation divides 1 number by another and gives the remainder. That's good for determining if something is an even or uneven number. So for instance, a modulus of 0 is probably 2 numbers are even. A modulus of not 0, it's going to be some kind of a uneven number instead of uneven result. All right, so and then finally the other one will be the exponent. This is usually called the caret key. We're going to use that as the pseudocode, but as I said, in other languages that changes, and that just is it's this, right? So x to the y, right? So it's to raise the number to the power of something. Okay. So that understanding that just it's better just to see it practice. All right. So variable declaration and data types. So data types can be a very complex thing, where you have a lot, various data types that make things more complicated, or it can be pretty simple, as it is in Python. Another language, JavaScript, is another language that's a little bit similar. It only has like 4 data types. But so it's going to vary, okay? There's a lot of programming languages out there, and each one has their very own approach to it. So a variable declaration includes a variable name. So first of all, you have to come up with a name that you want to give your variable, and usually you define the data type. Now, in Python, you don't have to explicitly say what the data type is, but the data type is inferred by the value that you assign to a variable. So the second you assign a value, if you define what it is. So if I, for instance, have A and I assign to it 17, that's an integer by definition. But if I take A and I assign 3.0, then that's a float, you know, kind of a real number. Now, if I take A and I just say hello, it gets assigned a data type called string, okay? So in other languages, you have to say int A, float A when you're declaring things, so you can declare them without values, or string A. Okay, and of course the actual names that you use will depend on the programming language and its syntax and list of reserved words. But for now, you know, that's the general idea. So data type again is just a data structure of how data will be stored in memory. So you need the differences because storing an integer is easier than storing a float because of the decimal, right? You need to find out how many numbers you have to the right of the decimal and so on. So data type defines the type of data you intend to store in a variable. Integer stores whole numbers. Real or float stores whole numbers, also decimal numbers. Okay, just by convention, the programs will print something with the period to be explicit. And string is going to be any series of characters. So for instance, here's an example of how to do that in the pseudocode. You notice that it says declare real gross pay. So basically the only thing in pseudocode that I was missing is to add the word declare. So you add the keyword declare and then you specify the type. So in this case, real, float. It doesn't really matter to me if you write pseudocode and you call it float instead of real. I know what you mean. And so that's really what's important. Okay, I actually would prefer float just because it's more clear to me immediately what you mean by that. Okay? Are there any questions so far? Okay, it seems like there's no questions. So let's keep going. Again, variable. So here are more examples of data types. Sometimes you want to initialize your variables to 0 or some other value. That, you know, that's just so that you don't forget to assign a value. So that will just depend on the problem. But here's an example of that. So we declare 4 variables, all of them real. Test 1, test 2, test 3, and average. Those are the 3. Then after they're declared, now we're going to assign values to them. So we use the keyword set, and we assign 88.0, 99.5, 97.0. Remember, these operations are being done as processes in the program. We're not really taking inputs and outputs. And then finally, we perform an operation here. This one, we set average, which is going to be just, you know, as you know from your math classes, just test 1 plus test 2 plus test 3 in parentheses divided by 3. That's usually defined as the average. And then now you have in memory in this variable here, you have now calculated the average, right? And you just print it out. So notice again a string literal of your average test score is, you have comma there, and then you have whatever the result of average was, which is in memory and will be displayed there. So the output of your program would be your average test score is 92.5. Okay, so you have that as well there. Okay, so that's an example. All right, constants. So constants are just, you know, special type of declaration. So obviously things that are not going to vary. So a named constant is a name that represents a value that cannot be changed. A lot of programs do that, define, you just have a value that you really want to explicitly say, I don't want this to change. It's very useful for logic. It's always going to be that, and so you kind of hard code it. So it makes the program more self-explanatory, right? So it means it's just clear. If a change to the value occurs, it only has to be modified in one place. So that's another thing. Like if you use that variable a lot, if that's something, let's say you have a variable that you use a lot throughout, different programs, sorry, in one program you have a variable that you use a lot, you may just have one place somewhere on top of the program where you've defined the value of it, and then you're just calling that variable constantly. So it just makes it easier for you to modify. So for instance, an interest rate, right? Let's say that you have, thousands of lines of code that use an interest rate. Well, you really just define it in one place here, and then that interest rate gets used by a lot of the different modules, okay? So now let's take a look at this hand tracing a program. This is a little bit, like a little example. All right, so hand tracing, okay, this is very, very helpful to understand how your data flows through your program. So hand tracing is a simple debugging process for locating hard to find errors in the program. That just basically means you wrote a program, you're debugging it, also take out a sheet of paper with a pencil and just trace, okay, the value should be this now, then, you can be very structured like this and create a little table, but that's not required. You can be more informal and just start writing on a piece of paper. So it's good for locating hard to find errors in a program. It involves creating a chart, okay? Or, as I said, some informal approach with a column for each variable and a row for each line of code. So you can see that here, kind of, you have 9 lines of code here. You have them there as well. And then you have all the individual variables, test 1, test 2, test 3, average. You can see those there. Okay, and then you're just flowing through the data. So what's happening to the variables? So nothing really happens to the variables until step 6, right? And on step 6, you assign 88 to the variable. The other ones are not modified. Then on step 7, you add a value to test 2. So now the value of test 1 is still 88. That hasn't changed. And the value of test 2 now is 92.5. The other ones are blank. Then you perform the average calculation, right? And that just, on 9, nothing has, here on 8, actually this, oh yeah, this is on, can anyone tell me why this is undefined? Actually, why is this undefined here? What's the problem? What's the problem with that?
Is it because you don't know what test 3 is?
Exactly. You don't know what test 3 is. Exactly. Very good. Since you don't know what this is, you're adding 2 things that you know to something that, is pointing to somewhere in memory, but what's there could be garbage, and so it doesn't know what it is, and so it gives you undefined for average, which means it errored out. But then you just, by discovering that, you figured out, oh, I missed this one. Test 3, well, let's just say 1. Now next time when you do it, you should get a value here, okay? The display also doesn't work because there's, average is undefined, so it'll probably error out for you. Are there any questions about this? Good example. All right, let's keep going then if there's no questions. So documenting a program, that just means, you can be either external documentation or internal documentation. So nowadays, everybody just uses GitHub. As I said, you can also create documents that you save next to your file. So external documentation describes aspects of the program for the user and sometimes written by a technical writer. So it could be some kind of PDF, Word document, GitHub, that kind of thing. It's really just some information about the program. Then you have internal documentation, and that explains how parts of the program work for the programmer, also known as comments. All right, so these are the comments, the comments section. So, it's usually a good practice whenever you write code to write a little bit of comments. The more complex the program is, certainly the more comments you'll have to write. Comments are often distinguished within the program with, by line. So usually, we can use this. You'll also see in Python, you use the actual £. If you want to comment a block, you use 3 single quotes, right? And then you write, your comments in here. Makes it easier. So we'll explore a lot of that later. So defining your first program. So here, we want to calculate the batting average for any player, right? So, some calculation, that means, we have a variable batting average. We need to figure out hits. We're going to divide by times at bat. And that's going to give us the batting average for any player, right? So the number of times at bat versus the number of hits. So you need to determine what is required for each phase of the program, right? So, what things will you need for this program? Figure out inputs, right? What must be read? What will be done with the input, right? And what will be the output? So what are the inputs here?
The hits and the time at bat.
That's right. What will you do with the inputs? What is the process?
Bottom.
What term? Oh, batting average? Yeah. So, right. So, but in particular, making the calculation, right? So set batting average given hits and times at bat. And then the output would be displaying, what do you display? The batting average, right? Maybe some string literal that says, batting average, like that, right? So you're going to have a print statement of some kind or display. You want to write the pseudocode, and then you're going to say batting average, right? Notice the space there, comma, and then it's going to be that variable. So I'm just going to shorten it to batting average, right? Then comma, and then maybe, maybe just leave it like that. Okay. And so that's really the output that we want to have. And so we define it like this. So that's really what you're going to do this week. On Thursday, we will practice doing some of these examples, writing on the whiteboard. You guys will follow along and start solving some problems. So designing your first program. So as we said, inputs received, number of hits times at bat. Some process is performed on the input, so calculate the batting average. Divide the number of hits by the number of times at bat, right? And then an output is produced, the player's actual result of the calculation for batting average. And that's it, pretty simple. So the pseudocode then would look like this, right? So designing your first program, we declare integer, integer, hits, and at bat. Again, this is where some people may find it confusing that when we do this in Python, we're not going to have to write the word declare or the word integer. We're just really going to say, you know, maybe hits equals 0. It is really that simple. All right, and at bat, 0 as well. In other programming languages, you would actually have to do, you know, int hits semicolon or something like that, right? So I just want to stress that here because this is only pseudocode. This is only pseudocode, so this is not required here. So notice just instead we want to explicitly write the word declare and the data type, integer, integer, and then this one's going to be a real number or float. So once you've declared the variables, notice here you first sort of declare the variables, then you get the inputs for hits, then you get the inputs for at bat, also have an output there for what you're supposed to enter. Then we perform the process, right? We have a set batting average, hits divided by at bat, and then finally we print out the result. And this would look like this. So you can always just, you know, write this out on, you know, like on a console, terminal, Jupyter Notebook, and you're going to get your result there. You enter 150, 500, and then it's going to give you that batting average result. Okay? Are there any questions at this time? Okay, no questions. Now, to take the previous problem and now make it into a flow chart, okay, so that's the next step. As I said, we're going to first practice with these flow charts a bit. So the idea is, remember, you indicate where the program starts, where the program ends. Notice that when these start to get really complex, you can do things like this. Add a node with a letter, and that just says, okay, this ends at A, so that way you know, okay, in the next section, I need to continue where I left off at A. All right, then we have a process here, which is to declare the variable. So we declare integer hits, integer at bat, declare batting average is real. Then we have the parallelograms, remember, that are for inputs and outputs from the user. So that's going to be this one. So print out the message, input hits, print out the message for at bat, input at bat. And then another, notice here, a rectangle. All right, so that's for a process. So we're going to set batting average, which is hits divided by at bat. And then here we have a final output. A final output, another parallelogram there. Okay? All right. All right, so designing your own program. In summary, we discussed inputs, determine data needed for input, choose variables to store the input, process, any calculations to be performed, and output, determine what output the program will display, usually the results of the program's calculations. Okay, so that is sort of a summary. Okay, and that concludes the set of slides from the old. That concludes the set of slides from the old. You know, the old set of slides are mostly pseudocode related. Okay, as I said, what I want to do now is I'm going to share the screen for the new set of slides. So remember, as I said, what I'm doing this semester is I'm posting 2 sets of slides, the ones that are not, you know, programming language independent, basically, and then the ones that are programming language dependent, okay? So I will always try to do a little bit of this. So Python. This is your first official Python description, I guess, in the class. Okay, so again, as you can see, it's the very same topic, input, processing, and output. So I'm not going to go through the slides that are pretty much the same ones as the ones we just saw. I'm only going to focus here on the slides that are specific to the Python language. So now you have your Jupyter notebook, you know how to run it. And so I strongly recommend, when you have time, go through anything that you see in this slides that is Python syntax and type it up on your Jupyter notebook. Get a feel for it, work through it and get some outputs. That's really the best way of doing things, right? Just to get a feel for the language. Eventually everything will start to come together. So are there any questions before I begin with this set of slides? You guys can see it, correct?
I see it.
Yeah.
Yeah, great. All right. So as you can see, it's pretty much the same name. And so what I've done is I've aligned all of these so that they're consistent with each other. All right, so let's get started. So here, we talked about design a program, same thing, input, outputs, processing. Now in particular, where we were writing display in the pseudocode, we're going to be writing print. And that's just the print function in Python. We'll talk a little bit about specific comments, variables, reading inputs from the keyboard, performing some calculations. Yes, the slides are available. So all the slides that I'm using are on Brightspace. You can go over there. You can go to Brightspace under the first module. I think it's called inputs and outputs, something like that. And go there and just both sets of slides are there. Okay. All right. So let's keep going. Oops. All right. So designing a program again. Now more specifically, we've said that programs must be designed before they are written. So design the program, write the code, syntax errors, test the program, correct logic errors. So we talked about that. We've talked about this already. We've talked about what an algorithm is, a set of well-defined logical steps that must be taken to perform a task. So we talked about that. Pseudocode, we talked about that, so I'm not going to repeat that. Flowcharts, I've talked about that. You can see the same flowchart as before. We talked about inputs, calculations, and outputs. Okay, and now, as you can see, displaying output with the print function in Python. So what is a function? A function is basically someone else wrote some code for you, and you're just going to use it. You can use it kind of as a black box. You just have to worry about what are the inputs and the outputs to that function. So it's a piece of pre-written code that performs an operation. In our case, the print function in Python displays output to the screen. Right? I think we already did that in last week when we tried our Jupyter notebook, and I think I printed out hello world. An argument. So this is a word that you should know because there's a difference between, there's two words, variables and arguments. And variables are things that you declare in your code, whereas arguments, or in your function, inside the function or module or something like that, arguments are things that you pass to it from the outside. Okay, so usually, for instance, what I mean by that is that we have print, parentheses like this, and then we have hello. So we're gonna pass hello in there, and that is called an argument, okay? And so that's one, it's just a terminology, it's a type of a variable, but I just wanna, that's kind of how it works. And that's the main idea. We talked about string literals, so now just specifically to Python, as you know, it's a sequence of characters. It's strings. A string literal is a string that appears in actual code of a program. So letters, it could be numbers too, but it's numbers that you cannot do calculations of on them because they are treated as letters. Basically, it's a string. Now, one key thing in Python is, let's say you have hello. You have to store it within you have to write it within single quotes or within double quotes. You can't do this. You cannot start a string and a single quote and then do double quotes. So that's, not allowed. But these two are okay. So it must be enclosed in single quote or double quote marks. A string literal can be enclosed in triple quotes, and that's mainly when we're talking about comments. So like I said, let's say that I have, let's take for example this, right? And I want to, let's say this was a program. And right now the whole text is a program. But now I want everything to execute except this part of the code. I no longer want it to execute. So what I can do is I could write 3 single quotes there, 3 single quotes there, and that basically makes this what is called commented out. And so what that means is that that piece of code will no longer run. And that's it. You just have to put 3 single quotes there, and then where you want it to start, and then 3 single quotes where you want it to end. Everything in between will become in the code a string literal, and that's usually very common for comments. Okay. All right, so let's keep going. And you can see that comments, notes of explanation within a program. It's ignored basically by the Python interpreter. It's intended for explanations. And another way of adding comments is with the #, but this only works for a single line. So for instance, let's say that I want to comment out these 3 lines. So then I would have to do #, #. Each # applies to one of the lines. Instead of the more convenient, you know what? Because I have a lot of lines, I'm going to do 3 single quotes. This also comments out the 3 lines. So you have both approaches, and you'll use both. Okay. Okay. Another thing you might do is, this is code. You want to explain it a little bit, but just with a short thing. So you just do this. You add a comment. You can add 2, and then you say, note, whatever, right? And you write something on there. Okay. That's comments. That's something that you will do, all right, to better understand your own programs. Are there any questions so far, guys? Okay, no questions. Let's keep going. So now we're back to variables in Python, right? We've already defined what it is. And so we can use them to, to store data, reference data. So we have something called the assignment statement, which is that. Okay, the assignment statement has a general format of the variable name, the =, which indicates assignment, that it's basically like flow. So it almost means like this. Okay, whatever's on this side, send it into that. Okay. And then the expression, this could be anything. This could be a number, 7, 3.0, hello. It just depends on the type of variable that you're using, but you assign something to it. So for example, here we have an example of an assignment statement. We assign the number 29 to the variable age. Okay. And as I said, this is called the =, but it's not equality. We're not looking at, is this equal to that? Instead, when we only have one equal sign. It means assignment. For us to say, is this equal to that, we actually have to use two equal signs together. Okay, but don't worry about that right now. We will see that in the future. Okay. All right. So you know, these are things that you can try in Python already with your Jupyter notebook. Just, you know, type this up, age equal 29, and then do another line, print age, and then hit run, and you should be able to see the 29 printed out. So it's pretty simple. All right, I've said all of this. All right. We talked about this. You can only use a variable if a value is assigned to it. We saw that in the previous example where we had an error, right, because a value had not been initialized yet. Naming conventions, same pretty much conventions as we discussed in the previous slides. Read through these. I think they're pretty much the same. Python, just like in the pseudocode, allows you to display several things at the same time, variables, string literals, all kind of together. Items in the list of arguments are separated by commas, and they will be displayed in the order that they are passed to the functions. And automatically, you know, they might get a space, although I like to just put the spaces in there. Just, you know, for my own, you know, it's just my own practice, basically. Okay. Variable reassignment. Variables can reference different values while the program is running. That's why they're called variables, right? So they're going to change. You don't have to worry about this, but, you know, a Python interpreter has what is called garbage collection, is the removal of values that are no longer referenced by variables. That is kind of something you don't have to worry about, an internal thing. A variable in Python can refer to an item of any type. A variable that has been assigned to one type can be reassigned to another type. And so that's the example that I created A, and I made it 7. So that means at that point, that's A is an integer. But then later on in the program, I say A 4.0, and now that data type is no longer related to int, but it's now a float type. So it really, a variable that has been assigned to one type can be reassigned to another type very easily. So that's something that we'll see as we start doing problems and things like that. So Python is very easy at handling strings. Other languages like C, C++ is a little bit more challenging to handle strings. It takes, you know, a lot of declaration and a little bit of work. Python is probably one of the easiest languages for handling strings. Usually, the data types that categorize the value in memory, they are int for integer, float for real number, string for storing strings. Although we don't have to use those keywords, we can just easily, as I said, the value is inferred based on what you type in. Okay. Some operations do behave differently depending on the data type. For instance, if I do hello equal A, B, world, let me just, to make it easier, add a space there. So if I do, and then I could also have, so let's say A1, or actually just say A, B, and then I'm gonna make this one C, D. So if I do M equal A plus B versus N equal C plus D, where C is going to be 7 and D is 3. So if you notice, what's happening here is that A and B, I have assigned excuse me, I have assigned strings. But to but to C and D, I have assigned integers. So what's happening here is I'm going to, for M, the plus sign is going to perform not a sum, because those are strings, but instead it's going to perform what is called a concatenation. So I'm going to concatenate A and B to produce hello world. Whereas in N, the plus sign actually performs the math operation. So N is going to be 7 plus 3, which is 10. So that's what it means here when it says some operations behave differently depending on the data type. Does that make sense, guys? Any questions about that? So let me ask you that, okay. A question here. Okay. All right, so now this is a type of exam type question. Let's say I'm gonna pick the letter R. Oops. Letter R, and now I do A plus D. What do you think will happen there? What am I doing first of all? Anyone?
Well,
You're combining hello with 3.
That's right. So which operation am I going to perform? Do you see the problem?
Yeah.
In the previous one, A plus B, they're both strings. Okay, concatenate them together, you end up with hello world in M. For N, you do C plus D. And that's just 7 plus 3. Okay, the 2 integers, no problem. I'm going to add them. 10. But what happens when I do in R, hello plus 3? That's a string plus an integer. So that's not something you can perform. The program doesn't really know what to do. There's a couple of ways this could be handled, right? And so the simplest thing is it's going to error out. This is going to give you an error. Okay? So just be aware of that. And that makes sense. That's exactly what should happen, actually. You know, that something like that should just simply give you an error. Okay? Is this clear, guys? It sounds like
yeah.
sounds like it's clear. All right, let's continue. All right, so we've talked about that. You know, it can be, X can be a number in Python and then reassigned to a string, right? Take me to your leader, right? So either one is fine. Now, reading an input. So we talked about the output, which in Python is just a print function. Input in Python has a corresponding function, which is, you know, quite simply input, right? And it has the advantage that you can put in here a prompt, and that just means some variable of the message that you want to display. So the way it works is it's a built-in function. You type this, and then what it's going to do is it's going to basically ask you to enter something. Then you enter that something, and you assign it to a variable. Okay? So just be aware of that. So this is something that we can try out in programs, console programs, to get inputs, or when you're running your code in some kind of an editor. Okay. So reading numbers with the input function, you know, would be pretty simple. It always returns a string. It's a built-in functions convert between data types. So this is something that's a little, don't worry about too much, but because you're going to read some, so this, what might happen is, let's say you want to read in 7, 8, right? And then you want to add them. But when you add them, you're going to see that, instead of getting 7 plus, let's say 7 plus 3, which is 10, you're going to get 7 plus 3 equal 73. So what happens here is that the input function returns everything as a string. And so then the behavior of the plus is concatenation. So it just concatenated the two into the string 73. Does that make sense? So really what you have to do is when you get your inputs, maybe try to typecast them, okay? Just to be more explicit. All right, so don't worry about this stuff. We don't have to cover that right now. Okay. Then, as you know, we talked about math calculations, so that, that's the same thing as before. Just, as a clarification now, the symbols in Python, this is the exponent, that's the modulus, multiplication, 2 types of division, plus and minus. And of course, as you learn in school, you have precedence, right? So operator, precedence, and grouping with parentheses are important things. So let's talk a little bit about, and this is very common to all programming languages, but let's talk about Python operator precedence. So operations enclosed in parentheses, this forces operations to be performed before others. So anything in parentheses will be performed first. Then after that, anything in the exponentiation will be performed. Then after that, multiplications and divisions and modulus or remainders will be performed. And finally, addition and subtraction will be performed. So that's pretty standard, to what you've seen before in school. And then if you have same operators, then same precedence operators, then they will execute from left to right. Okay, from left to right. Right, so here's an example of how to type these in Python. So again, you can do this, already with your Jupyter notebook. Just, take something, x to the power, so 2 to the 8, right? Write that code. Try to get that output, right? Remember that you have to write 2 asterisks. The modulus, this is really nice. Sometimes when you implement complex logic, you use things like modulus, right? The remainder operator, it performs division and returns the remainder. So for instance, 4 modulus 2, the remainder is 0 because they're even numbers. 5 modulus 2 returns 1, right? So that's like this, right? So 2 times 2 is 4, 1. So this one is that one. That's your remainder. And so that is modulus operation. So this typically used to convert times and distances or to detect odd, even numbers. So it's got a lot of very useful applications. Okay. Any questions so far, guys? All right, pretty good. I mean, we've gone through the slides. So, excellent. And then I'll just remind you that on Thursday, now our focus will just be on practicing some of this. I'm gonna work through some of the problems. Okay, so that will be the plan. I'm gonna pick a few problems and just work on them in class. I'll read the problem and then I'll say, okay, now let's write the pseudocode. Now let's write the flowchart. And you guys follow along on your own at home. And then we'll probably try writing a little bit of Python code as well, and things like that. So make it a little bit more applying basically what we're learning here. So this is also very easy and great because it's just really taking what's in the slides and writing it and running it and making sure it runs correctly as intended. Okay. So, you know, we're going to have to convert, you know, our math into Python syntax. I already talked about this, mixing data types. Just read through that. Don't worry about this too much right now. I think that's a little bit of advanced. Breaking long statements. This slide, I don't like to do this. I'll be honest. Some people do this, breaking long statements into modules. I never do this. I mean, you can still do this. This is when you have one statement that's very long, and instead you break it up. So you do this, that, and then the other part, right? So, you know, one part, the other part. I don't like to do that. And you don't really have to in Python, to be honest. So you don't have to do this. And what I usually do is I just indent this further to the right so that it looks a little bit more readable. But so basically, don't do that. Okay, you can, but you'll learn that it's not necessary. Okay. And then this we don't have to worry about right now. More about data output. Yeah, so don't worry about this. Read through it, but don't worry about it. Adding new line characters, that's something that I don't think you need to worry about. These are special symbols. This is called a tab. This is called a new line. They're helpful for formatting, but a little bit advanced right now, so don't worry about it. We'll come back to that later. All right, formatting numbers. Yeah, so all these topics, formatting, we'll come back to. And I think that actually concludes the slide. So I think pretty much read until about here. Okay, so stop here. Right, and all the other topics really, don't worry about them for now. We'll certainly get to them later on. All right, so that's it for today. That, as you can see, those are the slides. That's pretty much the approach I'm going to take every time. Just go over both set of slides, kind of make sure I cover from a pseudocode flowchart point of view, and then tie it back to the Python language. And then on Thursday, we're just going to take these concepts and start working through some problems. Maybe, do a flowchart or two in class, and so on. And then I will probably assign to you your first homework assignment. It'll just be a few problems, not that many, just to kind of get you to practice this at home. Okay? Next week, we will move on to another chapter, the next chapter, which is going to be conditional structures and Boolean logic, the so-called if statements. Okay? So that's it. That's it for today. And I'll stay for a couple of minutes if you have any questions. Otherwise, I will see you guys on Thursday.